You're going to set them equal to 0. And you're going to come up with your factors. You can leave your final equation, and don't forget to make it an equation. It's got to have a y equal or f of x equal. It can't just be an expression. You can leave these in factored form. You can't leave these because we don't see those in our functions. So for these, we said this is called a conjugate pair. Don't just copy it down. Figure out what you don't know. Was everybody good with these two? If you set x equal 2, x equal 3, can you make a factor from that? We start like this. I'm sorry, x equals negative 2. So this should be a plus 2, right? Yeah. X equals negative 2, x equals 3. So set these, this is backwards. So set them equal to 0 now. These were your factors. All I want you to do is give me your factors. You don't have to FOIL them out. You don't have to do anything. It's nicer for us to see them in factored form. We can right away spot where your roots are. Now, these two came from your quadratic formula. Your quadratic formula looks like this. Oops, what am I talking about? We should write this over. Today, I don't seem to be able to write and talk at the same time at all. So here's your quadratic formula. If we did your quadratic, it came down to the very end, and this is where it came from. We had 2 plus or minus radical 3. That's where your zeros came from. So what we want to do now is work it backwards. To work it backwards, you have to know these two little formulas. Sum of the roots is equal to negative b over a, and product of the roots is equal to c over a. And like I said yesterday, let your calculator do this. Plug these two things in. 2 plus radical 3, like this, plus 2 minus radical 3. Let your calculator do that. Out comes the radicals. Your sum is 4. Set that equal to your formula. Again, we've got to get rid of one of those variables because one equation can only have one variable. So we let a equal 1. And then just go like this. So if negative b is 4, what is b? Negative 4. I got to just divide by 1, right? Not by negative 1 because I need b to be positive. Now, second enter. Pull it in your calculator. Make this be a multiply for a product. Let your calculator do this. These are conjugate pairs, so it's your first and your last. So it's 4 minus 3. And 4 minus 3 is what? 1. But let your calculator do it. So 1 is equal to c over a. And again, a was 1, so what is c? 1. So those two roots came from the quadratic x squared minus 4x plus 1. And that's the other part we put in here. See it? Let your calculator do those for you. You don't have to worry about conjugate pairs or your perfect squares. You multiply the first term and the last term. The radicals will go away because your middle terms are plus and minus. So let your calculator take care of that. Whenever you see anything with an I or a radical, it came off your quadratic equation, your formula one. So we want to reverse it. And the way to reverse it are these two little rules, which you learned in Algebra 2, but we probably just didn't use them very much. We just probably used them for one little unit and then moved on. But the Regents loves those two. Those of you taking the Regents again, that's going to help you on the Regents. The Regents loves the sum and the product. For Algebra 2. If you need to retake it, if you didn't pass it, that's a real, these are great things to remember, because that one you'll see again. Are we okay on this one? Okay. Then I gave you the last two We did number 3, so I gave you 4 and 5. Now, 4 has the highest exponent of 3. The coefficient is positive. So your end behavior says down on the left, up on the right. I should have 3 zeros, 2 terms, follow your pattern, 1 inflection point. This helps me out. I should get 3 exact zeros. My y-intercept is one of my zeros, that I do. So I do a y-intercept somewhere. Here's my y-intercept. Show me algebraically. Just say 0 minus 0 minus 1. Show it to me algebraically. Now, our other one was our x-intercept, our zeros, our solutions. Now, if we set this equal to 0, we can't factor that like we did before when we had everybody shared an x, everybody shared something, we could factor it. So instead, we have to synthetically divide. So go into your calculator and out of the 3, isolate one of those zeros. Best bet is to look in your table. See if you have something that has a 0 here, and we could see the 1. The other 2 you couldn't see because you'll see the other 2 are irrationals. So we pull out your coefficients. Don't forget the x squared. So check. 3, 2, 1, 0. Pull down the first. Once you get your synthetic division, you can always factor a square, a square one. So you went down to the square, and you can try factoring it, but this didn't have any factors that were real or rational, so we use our quadratic, or you could use your complete the square if you like complete the square. I tend to, if it's nice and simple and my middle term is even and my a is 1, I always complete the square. If not, and I have to factor anything out, then I just go to the quadratic. Your quadratic comes down to 2 roots. Now, this over here is where you came down to. Okay, wait, it was here. You came down to this, right? Then it has to be reduced. Everything has to be, like algebra 2, in simplest terms. So your radical, you have to reduce your radical. Radical 4 times radical 3 gave me 2 radical 3. Then, if I'm here, I'm going to write it over here. Negative 6 plus or minus 2 radical 3 over 12. I cannot cross out the 6 and the 12. Those are terms. But I can factor a 2 out of the numerator. And now I can reduce my factor. Do not cross out terms. This is the other part of your exact values. Okay? We find a max and a min. Your domain and range on your cubing functions are nice because they're all real numbers. So if if it's easy, label, and then you can label this way it doesn't get all crowded in there. This is a maximum because I increase, and I turn. But it's not the maximum of my whole function because my maximum goes up forever. So this is a relative maximum. Make sure you know the difference between absolute and relative. Can everybody find it on the calculator, the relative max? Second calc max, to the left, to the right? Yes? 3 decimal places. Find your relative min. This is a minimum point, but not absolutely the minimum of my function because it goes on and on. So it's my relative minimum. Now, I need a point for those. I do need the xy point. But when you do increasing, decreasing, when you do concavities, you give me x values. Because you're looking for the value of your function, which is your y, to be increasing or decreasing. So for my increase, I always read left to right. I make myself two little things, increase, decrease. So reading left to right, and I start down here, what am I doing? What's my y value doing? Increasing. From negative infinity up, it stopped right there at that x value. Oh, that x value is negative 0.527. Then what did I do from A to B? Decreased. Oh, from negative 0.527 to that minimum value, 0.527. Then what did I do from B to whatever? Increased. From 0.527 to infinity. Do your increasing, decreasing after you do your max and your mins and get rid of those. Now, we said three zeros, minus 1, 2 turns, we got 2 turns, minus 1, 1 inflection point. That comes with your caves. We have a cave that goes down. We have a cave that goes up. They share this one right there. So when we want to find the midpoint of something, we take the average of the x's from here to here. Well, they were both the same but opposite signs. So when I add these together and I divide by 2, I get 0. So my inflection point has an x value of 0. Plug that into your calculator. Second calc value. Plug in the 0 and you'll get a negative 1. Well, that's the only time you need the y for that. Again, just like your max and mins, that's the only time. Well, my max and mins, just in case we would have needed it for a range, but not in this case. And then do your caves. From left to right, you made a cave down, but you stopped right there. And then you changed your mind and caved up. So I caved down from negative infinity to the x value only, the 0. Then I changed my mind and I caved up from 0 to infinity. Yes. Which x didn't you get? Okay, you did complete the square. Want to take a look at complete the square? I'm going to leave the plus 1 out here. So what do you have to factor out of this first? 6. So we get x squared plus x plus something plus 1 minus something. What's half of 1? A half. And what's a half squared? A quarter. So this is where it doesn't get pretty. Times 6 is 6/4 or 3/2. Did you do that part? Mm-hmm. Okay. So 1 minus 3/2 is negative 1/2, right? You found your vertex. So well, for the quadratic part. So 6. So 0 equals 6. X plus 1/2 squared. Minus 1/2. So we'll add 1/2. Now, when you get to here, when you divide by 6, you're going to keep change flip. So it's going to do 6 over 1, flip it over, 1 over 12. Then you're going to take the square root. You're going to get 1 over radical 12. Are you with me? Mm-hmm. Then you're going to subtract plus or minus. Then you're going to get negative 1/2 plus or minus 1 over the square root of 12. Okay? And
it's not the square root of 1 over 12?
Yeah, but the square root of 1 is 1. So, yeah, then it's harder for you to get it back into a fraction. That's what I think must have happened. Because if you do this in your calculator, just, okay, do this.
My answer was right there.
Absolutely. But if you leave it like this, you're never going to be able to reduce it. So when you have a radical, break them up. And square root of 1 is 1, so then we have a little easier time. I will get the difference if you do it, complete the square. I'll see the difference. You still have to just make sure they're reduced. Any questions on this? Kind of messy in there. We completed the square. All right, let's hit the last one. The last one seems to be the problem one. Okay. So, how many zeros does this have? How many zeros? 4 zeros. 3 turns. How many inflection points? 2 inflection points. Okay. Now, because I'm a 4, it's even, and my coefficient is positive, my two ends are going up. My end behavior says up. When I graph this, I get my little W, and you can kind of see the symmetry in here. There's a little symmetry through the middle here, and you'll see it when you do your max and your mins. Let's do your y-intercept first. Your y-intercept takes this out, this out, this out, this out, and just do this for me. 0 minus 4. Just show it to me algebraically. Yes?
I have a question. When b is already a negative number, do you make it into a positive?
When b, which
When
one?
you're doing the algebraic expression, like you got 2 plus or minus square root of 5, do you, because if you reduce it, if it was like a negative 4, wouldn't that be negative 2 plus or minus square root of 5?
I'll do this one out if you want me to. I'll complete the square, or did you complete the square, or did you do the
Yeah, I
quadratic?
did complete the square. I'm just asking, how did you do a positive 2?
Okay, I'll complete the square, and we'll look at that in a minute, okay? We'll look at that in a minute. Okay, it's possible that it's a negative and I just missed it. Okay, now, here's the key. You have 4 zeros. You can only factor when you get down to x squared, a quadratic. Use your complete the square or use your quadratic formula, which means somebody's got to tell me 2 to use. So I have to go to my calculator, and I only see the 1 here. I only see 1 0. I got a little bit of a problem. I got to find another one. But I should have had 4 zeros. 1, 2, that guy's a double root. So that's the second 2. Okay, this one was a little trickier. So once I synthetically divide by 2, I'm only down to an x cubed, so I divide by my double root. I bounced off of that axis. I didn't go through it, which means it's a double. So divide again by 2. You're still going to end up with 3 that you're going to give me because one of them is a double. We just don't repeat the double. Synthetically divide, and you get down to here. Now, what Monasia was saying is, she's here, and she completed the square. So let's complete the square. So what's half of...
Oh, no, I didn't complete the square.
You didn't complete the square?
I did the quadratic.
Oh, you did the quadratic equation. I'm sorry. That one's a very nice one for complete the square as well, because A is 1 and B is even. So that one's a really nice one for complete the square. Okay, so A is 1, B is negative 4, C is negative 1. So 4, plus or minus, you get a 4 for that?
Yeah.
Okay. 16 minus 4 times 1 times negative 1 over 2. So we're going to get 16 plus 4, radical 20. This becomes radical 4 times radical 5. So 4 plus or minus 2 radical 5. You have to reduce everything. Now, don't cancel out your terms. Factor out a 2. And now, whoops. Sorry about that. Factor out a 2. And now I can take out my 2's. Okay? You sure you kept this a positive? Because the negative of a negative was a positive.
I thought it was a negative.
But B was negative, but your formula says negative B. So a negative of a negative is a positive. And this one's really nice to complete the square because it kind of fits into what you need. So half of 4 is 2. This is 4. This is 4. Look how much nicer this is. Add 5. take your square root, plus or minus, and add 2. So complete the squares nice when A is 1 and B is an even number.
Yes. So the goal when you do the quadratic formula is ultimately to get rid of the denominator and have regular plus or minus something.
Your goal is to break it down, keep dividing down by your zeros until you can get to an x squared situation. You can
No,
always,
for the like when you have it already, like when you do the quadratic.
oh, when you do this,
Yeah.
yes, you want to reduce. I have, if I'm right here, right, I see 2 things. I see 20, radical 20. I have to simplify that. So that's what I did first. Radical 4 was my perfect square, radical 5 my not perfect square. So I'm 2 radical 5. Now I'm divided by 2. If you want, you could always separate these and do 4 over 2 plus or minus 2 radical 5 over 2 and then reduce it. But easier, I find easier, don't cross anything out, factor, look at the top, consider this like an x. What can I factor out of this one? 4 plus 2x, the blessing. 2. Radicals work like variables. So instead of that, I had this. I can still factor out a 2. Okay? You need to give me the answer in simplest terms. Simplest form. Fraction-wise and radical-wise. The only thing that we get away with in pre-calc is we no longer have to rationalize a radical in a denominator. We don't do that anymore. We leave our radicals in our denominator. But everything else has to be simplified. So we went through your zeros. These guys, and if you want to label A, B, and C, because this is the lowest point, these are absolute minimums. And they're both the same because when you look at them, when you find your minimum, the y's are exactly the same. So they're absolute minimums. This guy is my relative maximum. Now, I was walking around and some of you were saying it didn't look right in your calculator, but yet you can see 20 on your table. Sometimes your calculator, for a 0, uses a scientific notation number. And you're going to see a number with an e to the -6 or the -8 or the -11. That means move your decimal place 8 positions or 11 positions to the left. Virtually, that's 0. Why it doesn't say 0 is beyond me. But you can call that, you can't call it a 1.8, whatever they give you. You got to call it a 0. And you could kind of have seen this one on your graph. You already used it over here. You used that point already. So you saw that point was 20. Okay, inflection points. Take A and B x values, add them together, divide by 2. And then go to your table, and go to your graph, and put in this value for x, and find me the y. The y's have to be the same. You have symmetry. You have symmetry over your x equals 2. Fine. Okay. Concave up, concave down. Are we okay with everything else that's here? Everybody good with concavities? This one had a lot. It had 3 different caves. 2 cave ups and 1 cave down. So here's a cave up, here's a cave up, here's a cave down. They shared these. So I'm caving up from -infinity to that x value. I'm caving down between those 2 x values. Then I'm caving back up from that x value on up. Yes.
Why do you keep making it 1.2?
You have to tell me where are you? Oh, why did I go out 3 decimals over here? 4 decimals? Absolutely. Oh, the reason I did that is because then you can put a 0 because I wanted 3 decimal points. So I didn't want anybody to ask me why did I only do 2 decimal points, so I put the 4th one in there. Yeah. When it rounds down to another number, and you can absolutely do that, but if somebody's saying, well, why did you only put 2 decimal places in the second and I don't have to put the 0? The rules of rounding also say if you need to round to 3 decimal places, you have to put your zeros there. So, you know, because that's the position they want it to. Questions? Everybody can do these.
We have like a review packet or something? Like for the test tomorrow?
Well, this was your review.
This is all it's gonna be on?
Fruits, these are just synthetic division. Okay, just to review this, because this is what's going to be on your test also. Yes, you synthetically divide to find your zeros, but when you find your zeros, what is your remainder? 0. So we knew from our remainder theorem that if it's a true 0, we'll get a remainder of 0. These are I'm just asking you, the directions are just going to say synthetically divide. So let's look at this guy first. My denominator has 2 terms. It just has one little term here, one little thing. I got my a is 1. I just set this equal to 0. Okay? Pull out your coefficients. What are they going to be? 1. Good. 2. So test it. x3, 2, 1, 0. Make sure you have that filler. Nope. Set this equal to 0. That's a factor. Remember, this is a factor. Set your factor equal to 0. Okay, so now, start. Bring down the 1. Multiply. Add down. Multiply. You always multiply. Go to the right. Add down. Multiply. Go to the left. Add down. Now, you decrease this from x3 over x1. What is my first one going to be starting with? X squared, x2. So this is x2, x1, x0. This is my remainder. Say it real simple. So I've got an x squared minus 2x minus 4. This was not a 0. This is just a regular divide. Minus 6 over my denominator. That's my answer. Come on, pick up a pen in that hand. I'm practically giving you what's on the test tomorrow. They're going to look identical to this with a few numbers changed. So can everybody do that? Okay, so there's no reason why we can't do this one. Now, this guy, he's missing a little term in here. He's missing x to the 1. Right? It's just missing. So how many terms do we have in the bottom? 3. We can only use the last 2. And this coefficient is 1. So this one has a double divide. We're going to take this one out the opposite, which 0 can't come out any other way but 0. And we're going to take this one out the opposite to be negative 1. Okay, so now, double divide. Give me the coefficients for the numerator. So let's check. 4, 3, 2, 1, 0. Good. Okay. Always bring down the first one. We need a starting point. We multiply from the left, we go to the right. The trouble is we have to multiply twice because we have 2 things sitting on the left-hand side here. So what is 0 times 4? 0 to my left. Don't forget your negative 1. What is negative 1 times 4? To the left of that. I'm sorry, to the right. To the right of that. Now, add down the closest column. What do you get? Let's multiply again from the left to the right. 0 times negative 3. 0. Negative 1 times negative 3. 3. Go to the right of that. Stop. Add down this column. Negative 4. Multiply again. 0 times negative 4. 0. Negative 1 times negative 4. 4. you're at the end, add everything down. 3, 2. So we did front end, we did an x4 over an x2. So what is this going to start with? X squared, x2, x1, x0. Now, that means these two terms are my remainders. Because I had 3 terms on the bottom. So it's going to give me more than one remainder there. So work it backwards. x0, x1. So 4x squared minus 3x minus 4, just stick a plus sign here, and 3x plus 2 over x squared plus 1. Okay? The only one that gives you trouble is when you have more than 2 terms on the bottom. If I gave you 2 terms that look like this on the bottom, remember what you had to do? You had to factor out the 2 because a wasn't 1. And set this equal to 0 and later divide by a 2.
Can you do one like that then?
I didn't give you one like that.
You didn't.
I didn't.
Oh.
But remember that we do have that situation
Yeah.
for a synthetic division. Okay?